Of upthrust using a cantilever method. We have different methods of determining the upthrust. This one is a cantilever. This is a table. We have the meter rule. This is the clamp, G clamp. Then I have the meter rule again, horizontal meter rule and vertical meter rule. This is the rotor stand. Then this is a mass. This horizontal meter rule is mounted at 10 cm from the bench, and this object is put at 80 cm. Then we have 20 cm remaining at this point. So you mount the mass. Before you put the mass here, you first of all determine the original length. You determine the original length A0 before the mass. Then when you put the mass here, this thing will deflect downwards. Then you record the new length, that is this point A. So the A minus A0 will give you the deflection. Then after the whole experiment, you now dip this object in water. When you dip it in water, you now check the weight, the length when it is in water, and then notice the length when it is in what? In air. So after that, you take the various readings. So that is the experiment, how the experiment is going to look like. Thank you.
Allow it, don't touch it so that you stop that dangling.
What is the value? Is it A0 or A? A0, right?
Very well, yeah. It is almost 32. That's 1.5.
That's 1.5.
Yeah,
That's it.
That's 1.5. Yes. Avoid roll.
Don't touch the body, the bottom, every part of that this thing, beaker.
yeah.
That's 1.5. That's. So this is 31. So 31. 31.
So now this is the table of value, and we have the masses. These are the masses. When you have a mass of, and we put a mass of 50 grams, this is the length when it is without any mass. Do you get it? The original length without any mass. Then when we put a mass of 50, the length becomes 30 point this. Mass of 100, we have this, and so on. Then this is when we put this mass in water, we notice that the length has what? Decreased. This is the length in water, this is the length in air. The length these are various lengths in in water. Why these are the various lengths in air? But these are the masses that gives this length. Now this one is a deflection. The deflection here is the length in air minus the original length before the object is being slotted. Then we have these various, this one minus this will give us this 36.6 minus this will give us this, and so on. That gives us this D. Now this one is D prime, that is the deflection in water. And that's how do we get this? We say A prime is 29.1 minus 24.7 give us this. All these terms here, all these values here minus this will give us these values. Do you understand? So this is how we get the table. Any question? So that is the table. But as we don't have time. 4.40. 4.40 is you have 29.1 minus 24.7, and that gives us this, and all these values here minus this will give us all these values. So graph of the deflection in air against the deflection in water, we have a linear graph, a linear relationship between this and the deflection in air and deflation in water. So the graph is a straight line graph that starts from the origin. So this is the graph, and the slope of this graph is this. That is the deflation in air over deflation in water, and that gives this. And this value here, let us check it out. The value here, 22.5 minus 20 points this. So this is the slope. The slope of the graph is change in d over change in d prime, and that gives us this. D2 is a positive graph, so we have d2 minus d1 over d1 prime minus d2 prime minus d1 prime. So this d2 is this point here, which is this value. This point is this value, and this point 30 is this value here. 9.5 is this point here. So that's how we got this. This minus this 33 point, this will give us this. This minus this is this. So the result becomes this. And this verifies Archimedes' principle. Archimedes' principle. Upthrust is lost in weight. When a body is immersed in water, common experience shows that the weight of the body becomes lighter. But when it is out of the water, it becomes what? Heavy. So that is upthrust. So that is what Archimedes' principle states. When a body is totally or wholly immersed in water, it experiences an upthrust, which is equal to the weight of the body display. What is this upthrust? The apparent loss in weight. That is the upward force that supports the body when it is immersed in what? Water. And when the weight, this table, the table of value here verifies the law of the upthrust, which says that the weight in air is higher than the weight in what? Water. So that is the end of the experiment for today. We'll see you next month for the next experiment.